Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're looking at question 34 of the Caringbah 2020 trial. If y is equal to tan squared x, find the values of the constants a and b such that the second derivative is equal to ay squared plus by plus 2. So that means we need to differentiate this function y equals tan squared x twice. Now this is sort of like saying we've got y is equal to tan of x squared. So in order for us to differentiate this, we need to use the chain rule. So y dash, or dy dx, let's use dy dx. dy dx is equal to, I'm going to bring down the power, I'm going to reduce the power by 1, which is that, and then we need to multiply by the derivative of what's inside the brackets. Now what do we get when we differentiate tan x? We can go to our reference sheet in case we've forgotten. When we differentiate tan f of x, we get f dash of x secant squared f of x. So I'm going to write here sec squared x. Now we can actually rewrite this because when we differentiate this the second time, you'll notice sec squared of x. We don't have that here. We don't have that, so we don't know what it's going to be. So we need to be creative in how we do this. We need to remember that sine squared x plus cos squared x is equal to 1. So here we're using secant. Secant is 1 over cos. So in order for us to get secant squared x, we need to divide each of these by cos squared of x. So divide that by cos squared of x, we get 1. Divide this one by cos squared of x, we get tan squared of x. So technically we've got 2 tan x times tan squared x plus 1. I'm just going to expand this out. 2 tan cubed of x plus 2 tan of x. Now this will be a lot easier for us to differentiate for the second time. So d2y dx squared, this bit here, we need to use the chain rule again when we want to differentiate this. So technically we can rewrite that as 2 tan of x, that's cubed. So let's just make u equal to that. If we want to differentiate this, we need to bring down the power. 3 times 2 is 6. So you've got 6 tan of x, reduce the power by 1, but then we need to multiply by the derivative of tan of x. Well, when we differentiate tan of x, whatever's inside the brackets, we get secant squared of x, okay, because we've already worked that out before, which is technically just 6 tan squared of x. Let's just put the squared inside the brackets, so we don't need brackets there. Lots of, well, we've already established that that is equal to this, tan squared of x plus 1. So I'm just going to write that over here. We've got 6 tan squared of x, lots of tan squared of x plus 1. But we still need to differentiate this. When we differentiate that, we get 2 secant squared x. Okay, let's expand these brackets and then we can tidy this up. So we've got 6 tan to the power of 4 of x plus 6 tan squared of x plus 2 lots of secant squared x. Now we just said secant squared of x is just tan squared of x plus 1. Now I can just expand this brackets and leave it like that. This gives us 6 tan to the power of 4 of x plus 8 tan squared of x plus 2. Now we need to remember that we let y equal to tan squared of x. I mean, it says it in question. So technically we can replace this here with y squared, and we can replace this with just y. This is 6y squared plus 8y plus 2. And therefore, a has to equal to 6 and b is equal to 8.